Hello guys, how are you? Today we are going to discuss about the distance time and speed time graph. So first we will discuss distance time graph, then we will discuss displacement time graph, then we will move towards the velocity time graph. Consider an object of mass m moving with initial velocity after time initial velocity say v, and after time t its final velocity will become u. So it is illustrated with the help of a graph. We also know that the velocity is defined as the rate of change of distance or displacement is called velocity or speed. So we can also write the average change in displacement or change in time. We can also write the change in velocity means final velocity minus initial velocity over time. So in distance time graph we can see when objects is moved from initial zero velocity to final velocity in different manners. In above graph the velocity is gradient of the graph. So if we find out the gradient of distance time graph, then we will get the velocity of the object. So the gradient in this case, or in the displacement time graph, or distance time graph, the gradient of the graphs give us the gradient is equal to the velocity, which is the velocity of the object. So we can write del x if this distance is x, which is rise is x, and run is dt, then we can write del x over dt, which is equal to the velocity. So we will measure in meter per second. So conclusion from displacement time graph, we can say that gradient is equal to velocity. So always remember that in distance time graph the gradient of the graphs is actually the velocity of the object. Next we will discuss displacement time graph and speed time graph. So speed time graph, if we plot a graph between the speed and time is along x-axis and speed along y-axis, because speed is time dependent quantity. So we always take we measure the value of the speed along y-axis. In speed time graph, the area under the curve give us the distance traveled. In this graph, speed time graph, the area under the curve give us the distance traveled. So this is a triangle and this is like a square. So we will find the area of triangle and area of other uh, figs. So area under the curve give us the distance traveled. So in the case of velocity time graph, we can say that in a speed time graph, the area under the curve gives us the distance travels. So area of triangle is half perpendicular plus base. Area of a square is base into perpendicular. So conclusion from velocity time graph, area under the curve is equal to the distance traveled. Very important points. Area under the curve is equal to the distance traveled. So next we will discuss about displacement time graph. So let an object is moved from origin to A with which show that positive gradient. When the gradient is positive, so the velocity of the object is go on increasing, and here the velocity is constant from A to B, and then from B to C the velocity go on decreasing. So here we have a positive gradient, and here zero or constant gradient. Here we have negative gradient. So we can say that in above graph from O to A we have a positive gradient or a positive constant speed, mean positive constant speed, constant increasing speed, but positive constant speed mean positive mean increasing speed. From A to B the gradient is 0. From A to B the gradient is 0, so we can say that, or a zero velocity, because in the displacement time graph the gradient is equal to the velocity. So when we will find out the gradient of distance time graph, then we come to know about the velocity of that velocity of the under considering graph. From B to C, we have a negative gradient. We have negative gradient or a negative velocity. So we can say that there is a negative velocity. So if we plot the same graphs according velocity, so from 0 to A we have a positive speed. In other words, the speed is go on increases, and from A to B the speed is constant because the gradient is constant. From B to C there is negative gradient and negative speed, mean decreasing speed. So next we will discuss about velocity time graph. So in velocity time graph, when we have a positive velocity then there is positive distance, and when we have a negative velocity then we have a negative distance. So in positive and suppose constant velocity, then decreasing, then constant, then decreasing, then constant. So here area under the curve is positive, and here area under the curve is negative. So in increasing velocity, we have positive velocity, then there is positive distance travel. In negative velocity, we have a negative distance travel. This example shows the relation between velocity time distance time graph, velocity time graph, and acceleration time graph. So we can say that suppose a man throw a ball up and come back and he catch it. Its graphically representation is illustrated in graph A, graph B, and graph C. So first we will discuss the velocity distance times graph give us the velocity. So its velocity from the graph we can say that the velocity is continuously changing, and its maximum velocity, maximum when constant here, then decreasing from this point to this. If O A, from O to A, the velocity is continuously increasing. From A to B, the velocity is go on decreases. Same in velocity time graph. So velocity in velocity time graph, when the poles is this is ground is on the maximum top, it will from this is the position of the man. So velocity time graph is when the ball is on the hand, so our velocity time graph is here as he throw up. So this is the path shown in the graph. When it will reach the maximum height, then it will come back. When it will come back, then the graph is along negative axis. So similarly, the acceleration time graph, in acceleration time graph, because this is happen under a gravitational field, so its acceleration is continuously changing under the influence of the gravity, which is represented by negative g and illustrated in this diagram. This is happens in gravitational field due to minus g. Thank you for watching.